Let's first of all look at the definition of a polygon. Now it's a simple closed curve that's made up of line segments. It has to be straight line segments, but there are different types. There is a convex one, and in a convex one every angle is less than 180 degrees. For instance, a hexagon. Now that particular shape occurs a lot in nature. Think of beehives, for instance. And polygon can also be concave, and in that case you get an angle that might be bigger than 180, like in a kite. A kite is a typical concave polygon. Now there are various types of polygons, and some of them have been given quite complex names. Of course we know some very easy ones, like the triangle. So let me now go through a list of these names. First of all, we look at the triangle. That's got 3 sides. We look at a quadrilateral, 4 sides. A pentagon, think about that building in Washington. That's exactly in the shape of a 5-sided polygon. We look at hexagon, talked about that earlier. Octagon, it's got 8 sides. And then a decagon has 10 sides. Now it is possible to work out the angle sum of each of these polygons. But before you do that, you have to know how to get the angle sum of a triangle. It's actually quite easy. If we have a look at this problem, why is the sum of the interior angles of a triangle 180 degrees, then you should draw a line parallel to one of the sides. So I've done that here in the diagram. We've got AB, a side of the triangle ABC. I draw this line parallel to AB. And what happens then is that that green angle there, let's call it the green angle, is repeated over there because those two are in corresponding position. That yellow angle there, that is repeated over there because that is in what's called alternate position. In fact, I've written that down here for you. And clearly the black one plus the yellow one plus the green one, if you add those up, will add to 180 degrees. The angle sum in a triangle is 180. Now knowing that, you can actually work out the angle sum of other polygons, like for instance a quadrilateral, because a quadrilateral you can basically split up into 2 triangles. So that should be 2 times 180, 360. Here we go. I've got here a list, the name first of all, we know 180. We know a quadrilateral then must be 360 because it's got 2 triangles in it. I've also listed here the angle if the polygon is regular. See, you just then divide by 3 in that case. You divide there by 4. And regular quadrilateral, by the way, is called a square. Pentagon, 108. And an hexagon, the total is 720. Each angle is 120. And here we get the mathematics into it. Here we've got a formula for n-gon, a general polygon. And we always get 2 less than the number of sides, multiplied by 180 to get the total sum of interior angles. Now that enables us to do certain problems. For instance, I've got the problem coming up about a duodecagon. Fancy name that is. Let's have a look at a duodecagon. Is a regular 12-sided figure. What is the interior angle equal to? Well, we know that the total sum, or I shouldn't say total sum, it's just the sum, isn't it? 10, 12 minus 2 is 10, lots of 180. It's always 2 less, so that becomes 1800. And if we then divide 1800 by 12, because a duodecagon has 12 sides, you end up with 150 degrees. 150 degrees is already quite close to 180. You can see that the more sides you're going to have in the polygon, the interior angle increases, you know, from a triangle when it is 60 degrees to a square when it is 90 degrees. Now we've got an angle there of 150 degrees. So that process, if you make a polygon with more and more sides, the angle becomes bigger and bigger.